This page for section 4.6, we want to name the slope and the y-intercept of the graph of each equation. When it's in y equals mx plus b form, like this one, it's really easy to see that the slope is 3 and the y-intercept's 8. But when you get trickier problems like this where y is not by itself, you have to do some work first. So what we're going to do first is we're going to subtract 3x from both sides. That's going to give you negative 2y all by itself on the left. And on the right side, we're going to have negative 3x plus 8. You want y by itself, so we're going to divide everything by negative 2. And when you do that, you're going to get y by itself. So we're going to have y equals negative divided by negative, that's a positive, 3 halves x. And then you have a positive divided by negative. That's going to give you a negative 4. Now you can see the slope is 3 halves. Also, the y-intercept is negative 4. Numbers 5 and 6, those ones are different. There's no x value here. There's no y value there. What do? Well, when there's no x value, this is a horizontal line. You need to know that horizontal lines have a slope of 0 and the y-intercept is 6. For number 6, same concept. There's no y value. When you just have x equals a number, the line is vertical. You need to know that. If it's a vertical line, the slope is undefined. And there is no y-intercept. A vertical line is not going to cross that y-axis unless it is right on the y-axis. Now, the reason we need a slope and a y-intercept is so we can graph equations of lines. So here's an easy problem. Y equals mx plus b. It's in that form, slope-intercept. The slope is negative 1/2. The y-intercept is 3. Plot that y-intercept first. Use your rise and your run to find the next point. We have a negative 1/2 slope. So your negative can be on top or on the bottom. It doesn't matter. I'm going to go down 1 and 2 to the right. And you only need to do that one time, but you can do it as many times as you want. Connect those two ordered pairs with a straight edge. That's what the equation of the line looks like. And notice how it's going downhill. That makes sense because your slope is negative. Let's look at one where it's not as easy. We don't have this in slope-intercept form, so we need to get it there. Get y by itself, so let's move this 6. I'm going to subtract 6 from both sides. So I'm going to end up with 3y equals 2x minus 6. Then I'm going to divide everything by 3 to get y by itself. Now I can clearly see, well, maybe not clearly, it's kind of tough to see, but you should be able to clearly see it if it's written neatly. Your slope is 2/3. Your y-intercept is negative 2. Plot the y-intercept. It's on the y-axis. Use your slope now, up to 3 to the right. This is an uphill line that reflects the positive slope. Numbers 11, 12, and 13 use completely different skills. So we will cover these in a different video. What we'll look at right now will be numbers 14, 15, and 16. We're going to choose the correct graph of the lines P, Q, and R for each equation. So for number 14, your y-intercept is 2, and your slope is 1/2. The y-intercept of 2 lives here, so that's line R. For number 15, we have a negative slope, so your line should be going downhill. That's line P. And for number 16, we have the same y-intercept of 1 as the last one, but it goes uphill. So that's line Q.